When some innovative caveman invented the bow and arrow, it was a huge breakthrough. The discovery turned the Homo sapien into an efficient hunter-gatherer. These days, archery has made a comeback in the hunting community, and it's even been reclassified as an Olympic sport. So you could say the caveman's invention is still right on the mark. Today's bows are definitely not primitive devices. Crafted with calculated precision, they make it easier for you to take your best shot, and the caveman would have been very impressed. To make a longbow, a craftsman cuts 6 strips of cherry wood, a little more than ½ centimeter thick, using a bandsaw. Then with a belt sander, he repeatedly thins the wood strips on both sides, tapering the ends a little each time. The tapering gives the wood some flexibility, which the bow will need to launch arrows into the air. With his bandsaw, he now carves a handle from a piece of wood. Next, he brushes super adhesive glue onto fiberglass strips and the tapered strips of cherry wood. He works swiftly because the glue will start to dry in less than an hour. Now he layers the strips. The fiberglass strips buttress the 6 glued wood strips on either end. This process is called lamination. Next, he glues the wood handle to the fiberglass and wood lamination. And he tops it with a piece of masking tape to protect it from scratches and glue smudges during the next steps. Now the laminates get the squeeze. He places them on a curved plywood shape called a bow form. He positions a steel heat strip, a rubber hose, and another plywood form on top of the laminates. He clamps it all together, then inflates the rubber hose with an air compressor. The pressure from the hose combined with the heat from the metal strip mold the wood to the bow shape as the glue sets. 1 hour later, he removes the laminates, nicely pressed and glued into more bow-like curves. Now he draws the bow form onto the newly curved lamination, following a template made of fiberglass. With his bandsaw, he cuts the wood along the lines he's just drawn. He cuts an arrow shelf. That's the notch for the arrow to rest as the archer aims. Then he trims the handle, making it a little wider at the center for comfort. Next, using a coarse-toothed file, he hollows out little grooves in the upper and lower limbs of the bow. They're called string nocks, and the string will loop around them. To strengthen the tips, he glues little pieces of fiberglass and moose horn over them and the freshly filed nocks. He clamps it in a vice grip to set. When it's dry, he files through the horn and fiberglass to bring back the nock groove. He smooths it with sandpaper. Now he glues another piece of wood over the handle to improve the look and feel of it. He clamps it together while the glue dries, and 3 hours later, he sands it. Next, he wraps the handle in a piece of leather and stitches it together with nylon thread called artificial sinew. Many years ago, they used the tendons of an animal for thread. The leather will make the bow easier to grip. With a gel pen, he writes a serial number on the back of the bow, along with the draw weight. This bow will hold about 20 kilograms of pressure in check when it's drawn. This is a Flemish string jig, a wood fixture with posts on it. He loops nylon string around the posts. This is how he measures the string. It's always 4 inches shorter than the bow. He cuts it with a utility knife, then rolls wax onto it to make it easier to work with. He measures some string. Then he twists 16 strands of nylon, 8 black and 8 white, into a braid with loops on the ends. He hooks the string on the nocks, and it's time for target practice. As he bends the bow, energy is stored. He releases it, and the energy propels the pointed projectile. That apple didn't have a chance.
A pulley is a wheel with a grooved or barreled rim in which you run a rope or belt. It's a simple device used to lift a load that's hard to access or too heavy to move by hand. Pulleys and multiple pulley systems are vital components of many types of machines. These pulleys are designed for use in small to large-scale electric motors. For example, fan belts in the air circulation systems of office buildings, factories, and mines. The factory makes its pulleys from a 50-50 mix of scrap iron and steel. The furnace heats the metal to 1,370 degrees Celsius, slightly above the metal's melting point. Workers adjust the chemical composition by adding carbon and silicon. The right recipe is essential for producing quality metal. In the furnace, the metal's impurities, called slag, rise to the surface. Workers use giant paddles to skim it off. Once the lab analyzes and approves a sample, they transfer the molten metal by ladle to a 30-ton holding furnace. This furnace maintains the metal at a constant 1,370 degrees Celsius, the required temperature for a proper casting. You can't pour metal this hot into a metal mold. The mold would just melt. So instead, the factory uses damp sand. Sand withstands intense heat by absorbing it. The machine forms the molds much the way you'd use a pail to form a sandcastle. It first constructs the bottom half of the mold. This filter will screen out any slag particles the molten metal may still contain, and these cores create empty spaces within a part. Now the machine forms the top half of the mold. They slip a weighted metal jacket around the finished sand mold. This keeps it from collapsing under the weight of the metal. Workers fill the molds right to the top. It takes from 30 to 45 minutes for the molten metal to solidify. They remove the weighted metal jacket, then dump the mold into what's called the shakeout. The vibration breaks the sand mold apart, releasing the metal pulleys. While the pulleys go off to be cleaned, the sand is recycled into new molds. The pulleys are in rough form. They still have to be machined to specifications. A robot places each one under a computerized camera. A visual recognition program guides the robot to position the pulley properly in the various automated tooling machines. The first machine makes the pulley's grooves. The next machine will drill holes in the hub for installing the screws. At the end of the machining process, a gauging system takes precise measurements and guides the equipment to correct any errors. This is a two-part pulley known as a variable pulley because it can run a belt at variable speeds. This tooling machine performs several operations on the male component. It machines the face and outside diameter on one side, then flips the pulley over to make the bore and threads on the other side. The last operation drills holes for two screws that will affix the pulley to the shaft of the electric motor. A touch of lubricant, and the next machine assembles the male and female parts. After setting the proper speed, the user locks the parts in position with a screw.